Okay, so here's review problem number 3. Spider-Man has lost his powers. He runs off the roof of a tall building at a speed of 15 meters per second and lands 45 meters from its base. How tall was the building? And then what velocity will he have on reaching the ground? So when we encounter a problem like this, the first thing I want you to do is to draw a picture. And when I mean a problem like this, I mean a problem where we have motion in two directions. So let's see. I'm going to draw what's going on. So here I have my building, and we don't know how tall that building is. So I'm just going to call it delta Y. Spider-Man is going to run horizontally off the roof. I know it's horizontally because nowhere does it mention an angle. And he will land 45 meters from the base of the building. Okay, so now I can see that my 45 meters is my range, my X. Okay, now that I've got everything drawn, now I'm going to go about solving the problem. The first thing we said we need to do when we have a problem that is a horizontal release, which is what this is, we need to find time. So that's going to be my first thing. Because time, we said, links both my horizontal and my vertical. Now, in the horizontal, we have to remember we have got constant speed. In the vertical, we don't. In the vertical, we have free fall. I'm just going to say FF. Okay? Now, what do I know? I know my X direction, and I know my speed in the X direction. Since we have constant speed in the X direction, we can say Vx equals X over T. And that means that T is X divided by V sub X. Or 45 meters divided by his speed of 15 meters per second means that it is going to take Spider-Man 3 seconds to go from the roof of the building to the ground. Now, in all that time, he's in free fall. So now I can find the height that he drops, which is the height of the building, by using my free fall equation. And since what I'm looking for is a distance, I'm going to use this equation. Now, since we're talking about a horizontal release, that means there is no initial y velocity, so that Vi drops out. So I can say my delta Y equals 1/2 gravity times my time squared. And when I hit that into my calculator, I get negative 44.1 meters. Okay, and that's the height of the building. That makes sense. It's a pretty high building. He landed pretty far away, so it should make sense that it would be pretty tall. Okay, now my second question is, with what velocity will he hit the ground? Now, that velocity comes from two things. Number one, his Vx. That's his velocity in the X direction. that he's moving forward. And as we said, that is constant. His other velocity comes from his Vy. We don't know what that is. That's his downward velocity, and that is due to free fall. We have to find that velocity, and then we can use the Pythagorean theorem to add that as vectors. So let's see, how do we get Vy? Well, we know his initial velocity was 0 in the y direction. So his final velocity is going to come from gravity and the amount of time that he fell. Well, we already know the amount of time he fell was 3 seconds. So I can say his velocity in the y direction is going to be negative 9.8 times 3 seconds, or, I already calculated it, negative 29.4 meters per second. That's the speed that he gained as he was dropping. So if we don't think about horizontal motion at all, if we just picture him falling off the roof, if he just fell off the roof, 29.4 is the speed with which he would hit the ground. But he had that initial 15 meters per second that he was moving horizontally. His final speed as he goes down is going to be the combination of both of those two speeds. So let's see. Vx is 15. Vy is negative 29.4. That gives me that his final speed, once I hit this into my calculator, is 33 meters per second. Now, I wasn't asked for an angle, but if I wanted to, I could find one. I could find one using trig. I could say the tangent of my angle equals my Vy divided by my Vx. I'm not actually going to solve it because I wasn't asked for it, but if you were, that's how you would do it. Okay? All right, I'll see you for our last problem that we're going to review, and that's problem number 4.